Good day guys, Bing here. Today we're going to try this adaptive family. So basically we can use this family to create something like this and use a point, a fifth point, to control the size of these the void. Okay, so let's start. So first we're going to use the adaptive family. Okay, so now let's start. So first I'm going to place 5 adapt points. Okay, so adaptive points, and make them adaptive. So 1, 2, 3, 4. These 4 points are going to be used for the panel, and the 5th panel is used to control the size of the middle, the size of the void. Okay, so actually I'm not going to use void because that will take a long time to calculate. I'll just use lines. Okay, so let's select 2 points, spline, these 2, spline, these 2, spline, and these 2 spline, and then select and make them a reference line. Okay, and then the next step is we need to dimension all these points, the distance between them. Okay, so but before each dimension, we need to set work plan onto the reference line, and then we can dimension the adaptive points. So let me change the scale. So yeah, all good. And then set work plan, pick dimension di, and another dimension, set work plan di, another dimension, set work plan, and di, and okay, so now we have all the dimension. So now let's create a reporting parameter. Let's call it RP1 and instance reporting, and this one is RP2 instance reporting, and this one RP3 instance reporting, and this one is RP4, so RP4 instance reporting, and okay. And then we're going to let me think, we're going to find a midpoint, and there are different ways of doing it. So maybe we can just connect these two, and then that's roughly the midpoint. And also select these 2 lines and make them reference line. And place a point, you draw on face, draw it on this reference line, select this point, and use host point by intersection and pick this reference line. So we have this point. So now if I move any point, so this point will always be actually I think it's okay. So that's fine. Let's just leave it for now. We will see whether this point is good or not, it's or bad. So now the next step is select this use a reference line, circle, draw on work plan, set a work plan, pick the horizontal work plan of this point, and draw a circle. I'll create a radius parameter, so let's call it R, and instance, and okay. So now what we need to do is we want to use this reporting parameter to control this radius of this circle. So when we change the shape of this one, this circle it will not go outside of this shape. Okay, so let's try. So the idea is we want to find the smallest, the shortest edge of these 4, and then divide that by roughly 2. Okay, so now let's do it. So I'm going to just do let me just do a screenshot so I can sketch. So okay, so what we are going to do is first we're going to find which one is shorter. So from RP1 and RP2, so we can use if. So RP1 smaller than RP2, then the shortest one is RP1. Okay, otherwise RP2. So this is the formula to find the shorter one between RP1 and RP2. And then we can have another one exactly the same. We can RP3. If RP3 smaller than RP4, then it's RP3. Otherwise RP4. And then we can use we can compare between these two. So which means if bracket this one smaller than this one, and then this one, so I just put this here, otherwise this one. Okay, so this is the formula for to find the smallest shortest edge in these four. Okay, so let's do it. So I'm going to go to family types, and I'm going to type that formula in here. So basically it's if if RP1 smaller than RP2, then it's RP1, otherwise RP2. Bracket smaller than if bracket RP3 smaller than RP4, RP3, RP4 bracket, then if bracket RP1 smaller than RP2, RP1, RP2, then if RP3 smaller than RP4, then RP3, otherwise RP4. So I think this should work. So let's try. Yes. So this one will find the smallest. You can see currently the smallest is RP2. So we get exactly the same as RP2. So apply. Okay. So now let's have it. Okay. So now we have the radius, but of course we need to. We can't use this. We can't use this for the radius. We need to divide this by a number. So let's try divide by 2. Apply. Okay, so now let's just move this point to see. It's okay, but I wanted to try to make this a rectangular shape. Okay. Oops. Okay, so roughly a rectangular shape, because I know that when this is a rectangular shape, if the radius equals half of the smallest smallest side, this will touch this line. So this we will have some issue if we're doing void. So what we can do is divide by 2.1, so slightly smaller than that. So we have that edge. So I wanted to have another test everything. Okay, so it looks like we will have some issue when the shape is like this. So what we can do is we can move the point. So instead of use these two, maybe we should use different method. So let's try. I'll delete this first and delete this line, delete this one. So what I'm going to do is I'll just draw points and use draw on face and find the midpoint. You can type SM, and then select them, connect, select these two, connect, and select these two and make them reference line, draw a point, draw on face, select this point and use intersection. So now we have this point here. So reference, circle, draw on world plan, set to world plan, tab, pick, draw a circle, create a radius, select and apply this to it. Now it's better than before. Okay, so you can see, although it's still close to the edge, we might have set some. Yeah, it looks like we might have issue when from here. Okay, but I think it's better than the previous one. Okay, so let's just use this. So yeah, I think this is it. I'm not going to create a void or a solid. I'll just uncheck this box to make it a line, so we can see this when we apply this onto a mass. Okay, so now let's have a test. So I'm going to create a conceptual mass, and so let's create a very simple, I'll just do a line. Okay, so and then create a form and maybe make it a little bit more rectangle, square shape. Yeah, that should be enough. And I'll just divide the surface, and I'll just make 2 meter by 2 meters grids. Okay, so now I'll select this and turn on the nodes. Okay, and also before I place that one, because we have 5 points, I'm going to place a point, draw on work plan, and set level. I'll just place it here. So maybe I'll just lift this up a little bit, roughly in the middle. Okay, so this point is for the 5th point. Oh, actually I forgot to do that. So let's go back. I haven't done anything. So what we're going to do for the to the 5th point is we're going to connect one of those points and create a reference line and set work plan onto this reference line, the 2 dimension, and we will create another reporting parameter. So let's call it RP5. So this reporting parameter will be used to control the size of this one. So eventually we need to add this RP5 into the formula of R to control it. Okay, so let me think. So what's the next step? Okay, so let's have a look in family types. So we need to put this one RP5 into here and then control. So when this RP5 become very small, and when this RP5 is very small, we want this R to be very small. And when RP5 is very big, and then this R is close, should be close to this the current one. So this one. Okay, so let me think. 2.1, how do we do it? I think I did something like divide it by bracket 1. Yeah, can't remember. Anyway, let me just open I did one before, so I'll just open that up. So I think I did this one. Yeah, so I'll open this one. Okay, so yeah, so this is it. So you can see all these circles, the closer to this point, the smaller, and then all these bigger on the edge. So I'll just have a look. Oh, sorry, just need to select one of the family and edit. So have a look at the formula. So this is what I did, divide by 2.1, then divide by 1 plus n. So actually I create another parameter, so I can control it. So it's not fixed, the scale of it. So okay, I create another one, n, which is a length. Okay, so a length. So I'll do a screenshot. Okay, so I'll do a screenshot and I'll just move it to my other screen. So okay, so now let's go back to this one. So go to family types. So so first I'll just create a new length parameter. So it's very important when we do this, because if we use a wrong type, it will Revit will tell you inconsistent something. Okay, so I'll just call it n as well. So instance. So this is a parameter which we can type in a length to help us scale the size or the and then I will use this one. Let me just have a look. So divide, so all this number divide by a bracket 1 plus n divide by rp5. So this is the formula I use, but I believe there's more ways of doing it. I think this one's a little bit not very simple. You can find a better way to do it. Apply. Okay, so now let's have a look. If I drag this point close to this point, this become very small. And if I move this away, and then the size will become bigger. So eventually, so if you go further infinity, very miles away, it become very, very close to the maximum, which is the smallest stage divided by 2.1. Okay, so now let's load this into which one? This one, family 12. Okay, so let's load this into family 12, and so now we can place it on this divided surface. So 1, 2, 3, and 4, and 5, the fifth. And you can see if I move it close to here, can't say, but I'll just place it on this point, and then we can select this point, and not this point, not the point number 5, but the tab. Let's select this one. Okay, so now if you look at this circle, so you can see it becomes smaller and become bigger. Okay, so now we can select this divided surface, and let's try repeat, and this should apply this family onto all these divided surface. Yep. And it looks like we have some issue here. Not sure yet, but just let's have a look. Okay, it looks like I think it works, but it's not very clear. So you can see these smaller, these are bigger. So now what we can do is the one I just said. So I have this formula, this parameter here, so we can control this in this conceptual mass. So let me try if I type in 220k and see if it will make any difference. Yeah, I think that's slightly different. And also I think if I move this to, let me just move this to a little bit closer and see what happens. Okay, that's better. So, and also let me just if I change this one back to 10k, okay, so basically this is it. And you can, so this is just line work, and if you create, so for example, you can create a solid, and then you can create a void. So use this. So I'm going to check this box reference line, and I create a void to cut this solid. let's go the other way. Yeah, so that's okay. And now let's try overwrite. Yeah, this will usually take longer because a lot of void. So that's always something I'll try not to do, because void, and there will be a lot of issue. And oh, yeah, looks like we have some issue with the orientation, but I don't think. Oh, actually, I'm not sure. We might be able to try these different. Let's try maybe try a different one. And if it doesn't work, I'll just give up. Okay, this is not what we're talking about. We're talking about how to control the size. Use this 5th point. Okay, so and also there's a lot. We can also play with the formula to create different patterns. I'll show you once this one's finished. Okay, so it looks like we changed that point and they fixed it. So yeah, so this is it. And also I'll quickly show you. I just had a play. I'll just I think I have a file. I'll just open I did a screenshot of a formula I just did. Okay, so here it is. So I just had a play. So it's very similar to the one we had. So 1 plus, and I use sine into it. So this, and what I oh, hang on. I think I didn't save that file. That's fine. We can apply it to this one. Okay, so let's apply it to this one. So what I'm going to do is I'll just bring up this. I'll just move it onto my other screen. Go to family type. So we didn't need to change. We don't need to change anything in the model. We just need to adjust the formula of this. So I'll just do it here. So for the y, so which is actually I'll just use x. Okay, so and I'll remove this for now. Change this to x, and I'll change. Oh, sorry. I'll remove this one. I'll remove this part and go to x. Oh. Does that my Revit is not working? Does that mean I can't? Oh, it's okay, but hang on. X is reporting. Oh, should be n. Yeah. So sorry. Yeah, my brain's not working. So we need a y, and the reason why we need a y is it needs to be a number. So this is x reporting node, n is length. It's not right. So we need a number parameter. So y. So a number. And yeah, I'll call it y as well. Instance, okay. For the y, I'm going to use sine and brackets x divided by 1 times 1. I'll explain this. Okay. So last one. So here, so x is a length. We can't use sine length for sine, because for sine we need a degree. Okay, so what I did is x divided by 1, and the Revit will consider this one as an angle, or no, as a length. So x divided by 1 becomes a number. Okay, x divided by 1 becomes a number, and then I times 1 again, and then Revit will consider this one as a 1 degree. So if I click, you will see if I click here, now we need to type the degree. So I think it should be Alt 248. Yeah. So now let's try again. Yeah. So you will see Revit consider this one as length. So x divided by 1. X is the length. Length divided by length become number. Number times degree, still degree. So we can use sine degree. And because sine angle is a number between -1 and 1. So plus 1, so make sure it's always a positive number. So between 0 and 2. So now if I put this one here, so just to match the formula I have, it's 1 plus y. So yeah, actually we can just add plus 2, so doesn't really matter. But if I click OK, load this into this one, I believe. Yep, this is family or OA14. I'll load this into this and overwrite. And you probably won't see the pattern because the number of these is very relatively small. We need to have bigger number so to see the pattern for this one. Okay, so it looks like a random, so you can see you can't really see a pattern here. Can you see a pattern? Probably not. So but if we do this, if we go select this, and also another thing is, so you can see it's just there's actually, you can't see it because all the reference line here. So I'm going to just do it now. So maybe I'll just do it now. IC, select all these reference line and change this one to not a reference. So this will remove these. These are, imagine there are lots of reference line between this point and all these families. So if you move your cursor around here, so you can pick all these, but you won't see them, but you can pick them. So sometimes it's very annoying. So you can do the, you don't want to pick some random families. So you can do this to avoid that. Just need to load this back into here, overwrite. Okay, we are almost there. And okay, so what I'm going to do next is I want to increase the number of these grids so you can see the pattern. So okay, so select this divided surface, and also I'll just show you now. You won't be able to pick any family or repeater by moving here. So okay, so it's easier to pick element. You can just move your cursor onto the element. Okay, so now divided surface, and we're going to, instead of 2000, I'll just make it 500 by 500, but this will take quite a long time. So I'll just pause my video and I'll be back. Okay, and this is it. Not very good. I think it's not very good. Actually, I'm going to try a little bit. Try one more. Okay, so I'm going to move this point away from this surface. So for example, move to here and see what happens. And once again, I'm going to pause because this will take me about 5 minutes to took take my computer about 5 minutes calculate. See you soon. Okay, so now it changed the pattern of all these. So as you can see, if I'm after I move this point away from that, and now triangle or circle, so create this pattern. Okay, so this is it. If you have any questions, please let me know. I'll just open this. Here, let me just go back here. So this is all we need. Thank you for watching. I'll see you next time. Thank you. Bye.